Hello and welcome to Tea Leaves Programming. Today we're programming like it's 1979, Haskell for Dilettantes. Today we're going to finish up homework number 3. Where we left off was right here on step 5, handling event. We need to implement this handle event function, and they do recommend a hint, which is defining a helper function called move from to. The instructions here, I found them very confusing, in part because they're saying it should take 3 coordinates. And if I look at this function, I would say this function takes 2 and returns a function because of how he parenthesized this. And it could just be that I'm not seeing it. So let's try and implement this move from to function first. I'm going to read it here. Take a position to move from, that's that, a position to move to, and the coordinate to adjust. If the first parameter matches the third, return the second, otherwise the third. You can use this function with maplist to update a whole list of coordinates. All right, well, let's try it out. Okay, so I copied the type signature here. So what do we say it's going? We've got a coordinate from, we've got a coordinate to, and we've got the starting coordinate, right? So I believe these are called guards if we want to do things this way. So if these two are equal, then we want to return 2. No, if these two are equal, right, if these two are equal, we want to return the 2 value. Otherwise, we just return the initial value. Is that correct? Well, I'm getting a syntax error, so clearly not. Oh, move from to. It's already defined elsewhere. So let's just cut that. It said line 33, I believe. There it is. And I'm just going to. All right. And in this function definition here that came with the starting point, he's not doing that. So I wonder if that's just a typo or if he's just playing by showing us that we could return a function from it. Let me make sure I got this right. If the first is equal to the third, then return the second, otherwise return the first. I think that is correct. All right, so there's our helper function. But we still need to do this handle event. React to the arrow keys only. Such an event can either succeed or fail. It succeeds if the tile moved to is either ground or storage or box. And if it's box, it has to be ground or storage. If the move succeeds, update, and there we'd be using move from to update the position of the boxes. Well, we wrote, I thought in homework 2, we wrote an event that did handle the arrow keys. So let me save our work here, and let's go back to homework 2 and remind ourselves what we did. Right? We had all of this code here to try a move and to check what we're moving to, etc., etc. I mean, this seems fairly generic, so let's move it over here. And we don't want the draw world. That came over. That shouldn't have. All right. Why is that wrong? Well, for one thing, we're not updating the state. And for another thing, the function name doesn't even match. Right. This is because all of these things were back when our world state was just the coordinate. And now our world state has a lot more stuff. So this code actually isn't going to help us in any deep way. But I'm going to keep it here so that I can refer to it. Let me comment it out. And actually, I copied the wrong version of this code. That's more like it. We'll just put a multi-line comment here. And we might end up uncommenting some of this as we go along. That's okay. All right, so handle event. All right, this is saying, so this is our wildcard. This is saying any event that we don't know how to handle, return the state as is unchanged. I kind of like that. So let's keep that wildcard case, but we need to handle cases above it. I think our starting position for our little man was in the upper left. So let's handle down first. All right, just like that. And now we have some state, which we don't know what it is yet. And we want to return some other state, which is going to be I think here I actually do want this. And this is a direction. We do not want to change the direction, but there's also this box list, right? I think that's correct. Try move, I think, can just be the same. I don't think any of that changes. And if I'm wrong, I'll find out. Okay, and then I don't have enough stuff in this state yet. So we have the coordinate. And then we have a direction, which if we're moving down is going to be facing down. And then we have the box list. So for right now, let's just leave the box list alone. Let's return the same box list. We're not doing that bit of updating. But if I've done things right, then this should now handle the move down case. So let's test it briefly. Okay, I expect the right arrow key to do nothing and the down arrow key to move them down. And it does not, so I'm doing something wrong. We put a test here earlier where we were just drawing the initial state of the maze. So we removed all of the interaction. So that's one problem. The other problem that I think is here is our try move is using maze. And I don't think it can. I think we actually want to be using one of the maze with boxes. Right? Is that what it's called? I think that's what we want to be using for this. Why not? Because this is, we haven't updated this to, okay. So for right now, I'm just going to leave it at maze and we'll circle back to fixing that. Let's see if our event handling works at all though. Okay. They move down. Oh, that little dude is so adorable. I love it. And then right and left and up should do nothing. Okay. Let's go ahead and just handle right, left, and up since we're here. Even though we know that this use of box list is absolutely wrong. Right, we've got right. Let's do up, down, and then up. Right. And then left. All of these need to just match. I hate this redundancy here. This feels like we should be able to do better, but I'm not going to worry about it too too much right now. Okay, I can move right, left, up. I can't go through walls. I can't move into boxes at all. We're not updating the box list or pushing it. Right, because the boxes are neither a storage nor a ground, and we have this can move to here, which is explicitly disabling that. All right. So now we have two possible things we can improve here. One, we can improve try move to deal with the maze with boxes, which probably means updating that. Two, we can handle the pushing of boxes. All right, well, to update this, we need this to be maze with boxes. As we said earlier, maze with boxes actually takes our list of boxes in addition to whatever coordinate we've got. So I think we have not passed that box list down into this. So this rapidly gets the fact that we copied this code over is actually almost at the point where it's not helping us all that much because we're going to have to refactor it so much that it's effectively different code. Well, let's see how much effort it is to refactor this. So let's just add the box list as our first argument here. Right. This becomes maze with boxes box list. Okay, well now it compiles. That's something, isn't it? Okay, so if we can move to the new tile, and this should be correct at this point, we can move to that coordinate. And then can move to becomes more complicated as well. Because you can push a box only if the space behind it is a storage or a ground, right? So I feel like we actually need, like, this is correct, but it's correct in a different context. I'm going to change this name to can push to. And it's really only for boxes. And we're going to keep our original can move to and change it. All right? Can move to box equals what? We can move to the space with a box if the next space behind it is also empty. Now, my abstractions here are just wrong. I need to tease this out somehow to make it neater. I feel like this use of a big-ass conditional is not actually helping me here. What if we restructure that? Right? So something like that. Right? Is that right? Okay. Now it's probably complaining that this is redundant. That's okay. So what we've done here, all I've really done is taken this if statement and refactored it into a guard pattern. Have I got everything there? No, because I need an otherwise. Okay, now that should be inclusive of everything we had before. So now that I've made this maybe a little easier to look at, what are we missing? Well, we're missing we're walking up to a box. The box is on some tile in front of us. We need to know what the tile behind that tile is. So we have this walk target, right? And the walk target is that next step. But we also want, let's call it a push target. And what is that? That we just need to give another coordinate, right? So that's going to be right. So this is the target we're walking to. This is the target we're walking to, and then if we basically do the same operation here again, we get the target that we're pushing it to. Okay. And both walk target and push target are of type tile in this world. So this is going to collapse to a tile type, right? Okay. So let's handle the box case first, because it's the special case. And so if walk target is a box, did I make those equatable? I don't know if I did. Deriving EQ, looks like I did. If walk target is a box and, no, yeah, I do need can push to effectively. We'll define it again. I know you've watched me create and delete this several times. Sorry. I've got a spare. There we go. Okay. And can push to push target. Then new coordinate. Empty. Ground. Right. Okay, so now we should be able to, quote, push these boxes around. We have not yet written any code to actually move the boxes. All this does is validate our ability to walk. So I'm not sure what's going to happen when we run this. Let's find out. I can move around. All right, and that's kind of what I would expect to happen. We're not updating. So I would expect what I want is for moving right here to fail. And it's not failing. This is letting us push those boxes. So there's a bug in our code somewhere. What is that bug? Right, this is actually pretty obvious because we put this in the condition of our guard. This guard is failing. And so we're falling through to this, which is just saying, sure, you could walk on a box. So that's pretty goofy on my part. So if the walk target is a box, we can put this over here. I hate putting a conditional here, but I'm going to. Let's try that. Okay, and that still works, and that does not. So that looks promising. So now we need to actually update the box list per the instructions. Well, try move actually has a lot of information here, and in fact it has most of the information we need to update the state. So maybe it is a problem that we're not propagating the state down into try move. Instead, we are kind of managing it up here and not doing a very good job of it, right? So what if instead of having what we've got there, what if we just had try move take a state? The state has the box list, which try move is using. The state has the initial coordinate, which is in the state, and the state has the direction. So why not just have try move take the state and return a new state? Isn't that simpler? I think that might be simpler. What does it look like over here if we do that? Right, would be try move 2 and literally just passing this state in. Right? And then the question is, have we updated, have we simplified try move itself or made it more complicated? Let's take a look. So, right, we've got that. Those are all things we had before with the same names. So, okay, now the error is here because we're returning a coordinate, right, which is not something we want to do. So if we can move to a given walk target, then we want to return right? That should be the same. And we need all of these, I think. Parse error on, but what am I doing wrong? Am I not, is the indentation relevant here? Maybe. Right, this is returning a coordinate. So this is we're returning the same thing case. So that also is going to look like that. This is the returning the same case. This is the only one where we need to be doing some work with the box list. So, yeah, I think that if we change all of these to use try move, we will get the same effect that we had before. The box list is not yet being updated, but now we're in a state where try move should be able to pretty easily map the positions of the boxes. All right. Well, let's go ahead. And furthermore, yeah, this all ends up looking simpler as well. All right. And you'll recall earlier I was complaining about the redundancy that I had over here. And now that's gone because it's essentially encoded down in here. All right, and I'll leave try move here, the old one, as a historical artifact. Let's make sure that it all works as well or as poorly as it did before. That's not working. So I did something terrible. What did I do that was terrible? Oh, because we do still need to pass this in. right? Because otherwise we're just taking the direction from the state. So it'll keep moving in whatever direction our little dude is facing. So that's awful. Right? And then that we don't need at all. And that becomes direction. I think that should do it. Okay, can move in all directions, cannot push there, can push there. Whew, that was more refactoring than I thought I would need to do to get this done. Maybe copying the code from the previous exercise actually hurt me more than it helped me. That happens sometimes. All right, now we have to move the boxes. So, in this case, this is our fallback case. We will never, the box list will never be mutated. It's really only in this case that we got to worry about it. And in fact, specifically, it's only in this case, right? And push target if we're walking into a box, then walk target is the coordinate. Well, I'm going to change some of these names. I think we need to be a little more careful about what we're saying. Walk coordinate is where our man, or our person, excuse me, I should not gender it, is going to step onto. And then this right here is the potential coordinate we're trying to push a box to. All right? All right. And maybe we might want to change this to like walk tile and push tile would be more, you know, I think it would. I'm going to do that. Walk tile, push tile. And this to me, like the Haskell argument against what I'm doing here. The Haskell argument is, look, you gave these things names and the names were wrong. And now now you have to change the names so that they're right. Why didn't you just name them X and Y and A? And my argument is, in order to understand what this code that I wrote just 15 minutes ago does, in order to even make that model in my brain, these things have to have names that are meaningful to me. So that's my argument for why I'm trying to give these things names that have semantic meaning to me. All right. I think that's right. If the walk tile is a box and we can push it to the push tile, then let me reformat this a little bit. Okay, and right here is what we have to change to get these boxes to move. And I believe we wrote a map function last episode. Map list, right there. And box list is a list. See, semantically, it helps me remember that. And so what we want to do, what does map list take? Map list takes a function from A to B and a list and returns a list B. And we wrote this move from to. And that might be why. That's why in the homework assignment, it was written this way, because if we go move from to Yeah, I think that's what's going on. Okay. So getting back down here. Map list, some function, and box list. And that function is going to be move from to walk chord, push chord. I think that's it. That fell into place once we were structured acceptably. Well, let's see if it actually worked. Okay. All right. I'll take it. That's not bad. That's a bug, but we're doing something. We know we are changing the box list. So we just need to figure out how we're messing this up. And it looks like when we do that, first of all, we're ending up with 2 boxes, right? Seems very screwy. And we've lost all the other boxes in the maze. So that's really interesting. Well, in theory, this map list should be harmless, even if we're not moving in a way that pushes a box. This map list should be a no-op. And I have a feeling that it's actually doing, I think this is the problem. Somehow I'm doing the wrong thing. So what if we do this? So we're just refactoring that out. And what if we always return moved box list? Right? We're only doing it when we return things. We're not doing it here. If this is all doing the right thing, then it should be harmless in the case where I'm not actually pushing a box. If it's doing the wrong thing, then what should happen here is, or what might happen, is I will take a step that has nothing to do with a box, and all my boxes are going to go freaky. Let's see what happens. And all my boxes went freaky. Okay, so I've got something very fundamentally wrong here now. And it has to do with how I'm mapping these boxes. So maybe my move from to is somehow wrong. Son of a gun. That's the problem. So here I'm saying, I wonder how many of you saw this error when I made it. If this and this are the same, then return our new value, that one. And then here I said otherwise, return that value, which is not the same as the value it originally was. Let's try it now. That looks good. That's a bug. That looks okay. So this is much better, but we still are wrong in one case. This case when we're trying to go beyond. Whoa, that's pretty great. That's a crazy bug. All right, so this feels a lot more tractable than what we were doing before. Let's try it one more time. So this case worked. And this case, what we want to happen is, let me get back down to try move 2. All right. This should be, we're trying to walk into a box, and it's the else case. Right. And it's because we're using move, we're actually moving the box list in that case. And really what we're saying is we want the original list. All right. A lot of cases here. Impressive. You know, you think a Sokoban game, how complex could it be? The answer is pretty complex. Okay, so that looks good. That looks good. Moment of truth. Nice. We also had a bug earlier where I was able to push this into a wall, and that's fixed too. So I think after much agony, we have handled the event. All right, what's next? Define an interaction, wrap it in resettable and with start screen so that pressing an escape key returns to the start screen. Start screen. Okay. Let's take a look. Well, he already gives us something that looks like a start screen, so I don't have to do that. Let's look at interaction. Is it as simple as... Oh, that's what this is for. So resettable, if we hit escape, we're going back to the initial state, otherwise any other key. So we actually need to wrap this. And we actually need to spell it right. Funny how computers require that. Okay. So it looks like when we're in the start screen, any key does nothing except the spacebar, which starts the game. So maybe we need to, let's try that. Okay, so spacebar starts. We might want to put something on the start screen that says space to begin. If the game has been won, you need to say so. Define a function is won, which is true if the game is won. It's won if every box is on a storage tile. Define two helper functions. Haskell is on storage. I think that this is clearly some sort of HTML bug there. So is on storage returns true if a given coordinate is a storage field, and all list, which returns true if all entries in the list are true, and then it can be implemented using these two functions and map list. Okay. Okay, so he hasn't. I've been bitten so many times that like I want to make sure he hasn't actually already defined these things. From chord to bool. What was the other one? All list. From list bool to bool. All right, let's implement these. For this, can't we just do yeah, I think that works. Okay, then all list. That's going to be a little more work. Yes, I do this sort of thing. What can I tell you? All right, so if it's empty, it's going to return true, right? If it's not empty, then is that right? I'm doing something wrong. Ah, right. I think that's right. So then we need, right? We don't need the coordinate, we don't need the direction, we just need the box list. All right, That's going to transform the box list from a list of coordinates into a list of trues and falses. And then we can use that to reduce that list of trues and falses to a single value, if we've implemented this correctly. Okay, I think let's throw something in handle event first. Handle event, it should be the very first thing we do, right? This sucks, but if I was really going to ship this as production code, I would probably refactor this. But I think that will accomplish that. And it was at this moment that Code World decided to stop saving my code. All right, Code World is saving again. So the last thing we need to do is enter the win state. We need to tell the player when they've actually won. So I'm going to do this by simply compositing an image called win state with everything else. And that composite is going to be blank if we haven't won, and will just be some message that says you won if you have won. So if we've won the game, then we can put some lettering in place. You won. Otherwise blank. I think that should do it. So as our final thing, let's test and see how this goes. Sokoban, press space. Can we win the game? We're going to push the boxes over here. Sokoban must be a solved game, right? There's always an optimal number of minimal moves. Moment of truth. There we go. We've won the game. If we want to play again, we hit escape because of that resettable interaction we did. And that is homework 3 done, and that is Sokoban done. So that is Haskell via Sokoban. I hope that you found this interesting to watch me make my many, many mistakes as I go along. Next week, I'm going to try something a little bit different. I'm going to move away from Code World. I know that it is a useful way to introduce new people to Haskell, but it is in no way how you would actually use Haskell if you were programming for a living or for really any project which you intended other people to use. What I'm going to try next week is a series of functional programming exercises taught by a class called the Data 61 class. It's somewhat legendary. I feel very ambiguous about it. I feel ambivalent is the better word. I feel very ambivalent about it. At the same time, it has a very unique perspective and a very interesting perspective on what functional programming means. So I'm going to take a look at that class with you, and for that, we're going to be using largely the Haskell REPL. We're going to be using an editor, in my case probably Emacs, to work on the code, and we're going to be using the REPL to inspect and test our results. So I do encourage you to come along on this adventure with me. The first episode, as with Haskell via Sokoban, will be set up, and then we'll start doing the exercises, and I'll probably break up the videos one module at a time. So thank you for coming along with me on this journey as we continue Haskell for Dilettantes. This is Tea Leaves Programming. Thanks for watching.